Next on the list, we have Alisa Buletek in Florida. She's a first-year grad student, and she'll be talking about a search for young stellar objects with a PASHION mission. Okay, you need to start from the name there.
Okay.
Alisa,
Can
have
everybody
fun.
hear me and see?
Yes, we can hear you perfectly.
Okay.
We can see your poster now. You have 5 minutes, 10 minutes until transition. Have fun.
All right. Thank you very much, Raphael. And hi, everybody. I'll just reiterate, my name is Alyssa Buletek. I use she, her pronouns. And I am a first-year graduate student at the University of Florida working with Adam Ginsberg. And today, I'd like to tell you about PASHION. So PASHION stands for the PASHION Alpha Survey of Hydrogen Ions. And it's a proposed small satellite mission whose goal is to survey the galactic plane in the PASHION Alpha hydrogen recombination line at 1.87 microns. Here's a little model of the PASHION spacecraft. One of the goals of PASHION is to be able to peek through the dusty interstellar medium to observe accreting young stellar objects, or YSOs. PASHION Alpha is a particularly good emission line to do this with because it has a high intrinsic line intensity compared to other hydrogen recombination lines like bracket gamma, and it lacks significant extinction. So here is an example of a YSO spectrum that has some strong PASHION series emission lines. And so our goal with this project was to try to demonstrate that we can use the emission line accesses of YSOs, of young stellar objects, to identify them as YSOs by making color diagrams that hopefully would show YSOs occupying some distinct color space from contaminants in the PASHION survey because of the fact that YSOs would display recombination line accesses. And in order to do this prep work for PASHION, we used H alpha as a proxy for PASHION alpha because it's easier to find large surveys of, and you can calculate expected PASHION alpha emission for a given object based on known line intensity ratios with H alpha data. So to create our color diagrams, we needed data from 2 different types of objects. We needed to have some examples of previously identified YSO candidates and also background sources that we didn't think were likely to be YSOs. And for each source in our color diagrams, we needed 2 types of photometry. We needed H alpha emission line photometry as well as wideband infrared photometry. And I have some flowcharts here showing how exactly we retrieved the data here in figure 3 and figure 4. But I'll quickly summarize by saying that we cross-matched several small and large catalogs to be able to get the requisite data for the different types of objects that we needed. For YSOs, we began with a small sample from Alcala et al. 2017 of on the order of 40 YSOs that were identified spectroscopically with the Very Large Telescope, the VLT. We cross-matched those objects with the Spitzer from Molecular Cores to Planet Forming Disks survey to get Spitzer infrared photometry for them. We also ended up adding a larger machine learning identified catalog of YSOs to that smaller sample. The ML identified catalog was using Spitzer data, and it's called SPICY. You can read what it stands for there. I won't say it again. And so we have the YSOs. Now we need the background sources, which we got the data for those by cross-matching several large galactic plane catalogs in both the infrared, wideband infrared, and in H alpha. And we also calculated expected mass accretion rates for the YSOs in our sample, given their H alpha minus R colors, which kind of came with that galactic H alpha catalog. So I'll show you some color diagrams now. Here is a figure which I'm calling the discovery potential of PASHION. it shows that we have the total spicy catalog here in teal. It's a Spitzer color diagram with 2 Spitzer colors on each axis. We see there's the total spicy sample in the teal circles, and then we have pink circles representing the subset of spicy that is covered by our galactic H-alpha catalog. And we see that not every source in the spicy catalog is covered in H-alpha. So this is a great place for PASHION to be able to contribute, as PASHION alpha is less sensitive to extinction than H-alpha. So we might be able to fill out some of this color space a little bit more. Getting to the sort of meat of the talk, I suppose. Here's another Spitzer color diagram, which demonstrates why Spitzer alone is not able to identify young stellar objects, shown in pink, and in particular, accreting young stellar objects, clearly accreting YSOs, in orange and also in purple, from background sources, which we show in green. So this is just using Spitzer data. But when we incorporate the H-alpha emission line data, we notice that if we consider sources that have a clear H-alpha excess, defined as to the left of the H-alpha minus R is -1 line, we're much more easily able to differentiate these sources, these accreting YSOs, from background sources, which tend to occupy a different place on the color diagram. And also, just as a quick metric, we're able to estimate some mass accretion rates corresponding to each of these H-alpha minus R colors. And we'll be able to detect with PASHION mass accretion rates of on the order of 10 to the -8 solar masses per year behind substantial extinction. So in summary, because I'm out of time, PASHION will be able to expand the population of YSO candidates by complementing large infrared catalogs like SPICY, and it'll help us peek through the dusty interstellar medium to measure the growth rates of these newborn stars. Thank you very much for your time. I'll be happy to answer any questions.
Thank you, Alisa. Excellent job. Alisa, how do you define a YSO?
That's a great question. That's sort of what this whole project was trying to determine. It's like, how can we quantitatively identify what is a YSO and what is not? I suppose a YSO, from my interpretation, is an object that is accreting mass from its natal cloud, a star that's still well, you can't really call it a star, I guess, an object that's still undergoing the process of formation. And we ideally would have some method to quantitatively determine whether or not a YSO is accreting. This is sort of our attempt at doing that. Of stating
the H-alpha, both the H-alpha and PASHION alpha emission come from the accretion.
Yes, they should be tracers of accretion processes. Okay.
Yeah, I study stellar populations extragalactically, and I can imagine how a satellite like PASHION would be helpful and applicable to nearby galaxies, you know. But I haven't thought about this in the YSO scenario, you know. Interesting.
Mm-hmm.
We have a couple questions. Mike Kuhn asks, out to what distance in the Milky Way would you expect to be able to detect YSOs with PASHION? And to what extent do you expect nebulosity or crowding to affect detection of YSO in PASHION alpha in massive star-forming regions?
Those are both great questions. I'm going to answer the second question first because I have a better idea of the answer. And my answer is you should go check out Michael Farrow's poster, which I think his project was mostly dealing with how to deal with the fact that we have lots of stars in a single small area. I think that is something that the project will have to take into account in our data analysis.
Right.
And out to what distance in the Milky Way would you expect? That's also a good question.
So Adam Ginsberg says, I'm afraid these might be more questions for my iPoster than for Alisa's. So
yeah.
if you're interested, look at Adam's poster.
I think that's a good idea.
Cool. Great job, Alisa. Thank you very much.
Thank you.
And so Adam posted the link for his poster there. Is there anything you want to clarify? You still have some time.
Let's see.
What's the most challenging aspect of this work for you so far?
I think the most challenging thing was actually doing these estimates of the mass accretion rates, which I did quite last minute. It was a recent addition to my poster. If anybody has been looking at my poster long term, we made a lot of assumptions, very simplifying and naive assumptions in these mass accretion rates. So that's why I said they're estimates. We assumed
Simple.
solar values for most of these values, which is likely not true for all YSOs. But it matched some other prep work we did for this project. So it was a pretty good estimate.
Good. It's not, that's how science is made in general. So yeah, excellent. Any other questions? Brian Svoboda asks, would PASHION use multiple epochs to study accretion variability?
That's a good question that I don't know the answer to. I don't know the expected lifetime of PASHION. That might be another question for Adam's poster. But
so PASHION is a small satellite, and I'm assuming it was proposed before the Decado, right?
that was just this was a NASA Pioneers proposal for this past session. So
excellent. Thank you very much, Elisa.
Thank you.